Here we deal with array of numbers. So we'll firstly focus on the types of matrices. We have a row matrix. So this one is a matrix where numbers are presented in a row. We can have numbers like 8, 6, and -5 represented in a row as an example of a row matrix A. We also have a column matrix. So this array of numbers here, numbers are represented in a column. We can have numbers like 4, 8, -12 in a column as an example of a column matrix B. So we define a matrix represented by both rows and columns as M by N matrix, where M represents the number of rows and N represents the number of columns. So the general representation of this array of numbers can be defined by this matrix C, which is M by N matrix. As you can see, we are having M rows and N columns. So these entries C11 until CMN are just constant. If you can see, on the first row you have C11, C12, C13 until C1N to show that these are the entries on the first row. On the second row we have C21, C22, C23 until C2N to show that these are the entries on the second row. On the third row, so, and also on the nth row. Similarly, on the first column, as you can see, you have C11, C21, C31, CM1. And so on the second column, you can see C12, C22, C32 until CM2, until you arrive on the nth column. So this matrix is just depend on how many number of rows and number of columns you are having. But if the number of rows and the number of columns are the same, then we have a special case. So this matrix will be called a square matrix. We can have a 3 by 3 matrix as a perfect example. Or we can have matrix C defined by this example here. So you can see on the first row, you have your entries as 4, 14, 3. Second row, 8, 6, -5. Third row, -12, 2, and 9. Similarly, on the first column, 4, 8, -12. On the second column, 14, 6, 2. And on the third column, 3, -5, and 9. We also have the identity matrix. This one only exists on a square matrix. So it's a matrix defined by diagonal ones and zeros elsewhere. But as you can see, these diagonal ones are starting on the top left to bottom right. That's how they should be. And elsewhere, there are zeros. So we can have an identity matrix of a 3 by 3 matrix. So this is how it's defined, as you can see. Another important type of a matrix is a symmetric matrix. For one to understand what is a symmetric matrix, let's firstly define a transpose of a matrix. So the transpose of any matrix is obtained by exchanging the rows with the columns of that particular matrix. So in this case, the transpose of our matrix C is defined by CT. So our first row is going to become our first column. The second row becomes the second column. The third row becomes the third column. And so with the last row becomes the last column. So that's it for the transpose of a matrix C. So a symmetric matrix is a square matrix defined by the transpose of a matrix equals to itself. So if the transpose of a matrix C is in fact C, then C is a symmetric matrix. We can have a perfect example for this. You can see that from this example, the transpose of matrix C is actually C, because when you transpose this matrix, your first row is going to become your first column, and your second row will become your second column, as you can see, and your third row will become your third column. So it remains unchanged, and for that reason, it's a symmetric matrix.